Hi there. This video is for enrichment for those students who already know how to draw Lewis structures. The molecules in everyday life have more than one central atom. They're much bigger than the ones you've been drawing. So in order to be able to understand observations of phenomena that you see in your everyday life, we're going to draw Lewis structures for molecules with more than one central atom. Most of the steps are exactly the same as what you already know. There's just a few additions. So first, as always, we're going to count the number of valence electrons, and I'm just going to go ahead and type these in here. So H has one valence electron, but I know there's two of them. Okay, so that means there's two valence electrons from H. O has 6 valence electrons, but there's two of them, so that equals 12 valence electrons. So when I add the 12 to the 2, I get 14 total valence electrons, okay? So I have 14 to work with in my Lewis structure. Then the next step says put the least electronegative element in the middle, the one with the lowest value. So if I look at my table, I see that H is, wrong table here. H is 2.1 and O is 3.5. So H is less electronegative than O, but the problem is H only forms one bond. How do we know that? If I draw the Lewis structure, Lewis symbol for H right now, I'm going to switch my drawing tool. H only has one dot. Okay. And if you remember, H is in the first row or period, and only 2 electrons can be held in that shell. So H only forms one bond, James bond. So I'm going to write that in here. H only forms one bond. And you should write that in your notes, okay? Or you should already have that in your notes, okay? So next, I'm going to go back to my drawing. Since H can't go in the middle, then who goes in the middle? And that is oxygen. So I'm going to put O, and I'm going to surround it with the H's. I only have 2 H's, so I'm just going to stick them on the outside, like so. Then it says put a covalent bond on step 3 between the central atom and the outside atom. So I'm going to go like this. But also, I must connect the middle guys together. Step 4. Add electrons to the outer atom to satisfy the octet of 8, but H only has 2. So if we look at what we drew so far, the line connected to H represents 2 electrons. Okay, that's 2 electrons. So these H's are satisfied. This is 2 electrons right there. Okay, I just want to add that into you. So it says add this rule. Actually, that was from before. You already have this rule. Count the number of electrons drawn and subtract from the total number. Okay, so if I count how many were drawn, 2, 4, 6, because each line is 2 electrons, and I know I started with 14, and I'm going to calculate here, first of all, 14 valence electrons total minus, and I said I had 6 electrons in the bonds, James bond, right? So 14 minus 6 is going to be 8 electrons left. That's what I have to work with to finish my Lewis structure, 8 electrons left. Add unused leftover electrons from 4b to the central atom. And we happen to have 2 central atoms, okay? So now I'm going to draw adding the leftover electrons. Remember, there are 8. And we always add electrons in pairs, okay? So I'm just going to change my drawing thickness so I can drop my dots. Whoops. Okay, so here we go. I add them in pairs. There's 2, there's 4, there's 6, and there's 8. Okay? And then we added this rule already. Count the number of electrons drawn in the Lewis structure. Check to make sure they equal the same number of total valence electrons in step 2. So I don't draw on that. Well, actually I could, it's fine. So here I'm going to change my drawing thickness to, and I'm going to change the color so I can count and you can see it. All right, so every time I count, I'm going to count by 2. So this is 2, 4, 6, 8, 10, 12, 14. So I drew 4 And then in step 1, oh, sorry, did I say 4? I meant 14. Step 1, I have 14 as well. So that means I didn't make any mistakes and my answer should be perfect. Let's try another one. Counting the total number of electrons in N2H4. So N is in group 5, so it has 5 valence electrons, but there's 2 of them. So now I have a total of 10 valence electrons from nitrogen. But I also have hydrogen, okay? So hydrogen has 1 valence electrons, but there's 4 of them. So that means times 4, there are 4 valence electrons, okay? And therefore, 10 plus 4, again, gives us 14 valence electrons. You won't always have that same number. We just got lucky. Putting the least electronegative element in the middle. Once again, H can never go in the middle because it only can have 2 electrons in its shell, meaning it can only form 1 bond. So I'm going to put my N's in the middle and the H's outside. Okay, so here we go. So my N's are going to go in the middle, surrounded by H's. So first, I'm going to write N here and an N here, and then there are 4 H's. So I'm going to give 2 to each nitrogen to be fair. Okay. And then it says put a covalent bond which equals 2 electrons between the central atom and the outside atom. So one there, and there. I'm also going to connect the middle atoms since there's more than one middle atom. Okay, whoops. Actually, we're supposed to show that below. So let me just undo, and draw it again down here. Okay, there we go. And I connect. Don't forget about this other guy down here. Recopy everything from the previous step and connect the middle atoms, okay? 4, add electrons to the outer atoms to satisfy the octet. H will only have 2. So H's, all of them are satisfied because they each have 2 electrons attached, okay? And now we count the number of electrons drawn and subtract from the total number of valence electrons. So if I count 2, 4, 6, 8, 10. I drew 10 and I had 14. So I'm going to type that in. Okay, so I had 14 total valence electrons minus I drew 10 electrons drawn, and that gives me 4 electrons left to finish my Lewis structure. Add any unused leftover electrons to the central atom. Check that all have 8 electrons except for H, which will have 2. So I'm going to redraw what I have above, and then I'm going to add my electrons in. So let me scroll up here. All right, so N, H, connect. Okay, and then, all right, it says I have 4 electrons left. So this one I can give 2 to, and this one I can get 2. Okay, and I'm going to always check that is the octet rule satisfied. Okay, and we'll look at nitrogen. 2, 4, 6, 8. That one's satisfied. Remember, this is a nonpolar covalent bond, so that's an even shared of they evenly share those pair of electrons. So those 2 electrons belonging to both nitrogens, 2, 4, 6, 8. Both of them are satisfied according to the octet rule. Last step, count the electrons that you drew. Make sure they match the ones in the first step. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14. Yippee yahoo. This one is good. So I'll write 14 electrons drawn. And then I can put a check next to it since I checked step 1. And they equal. Check. Okay, and now we have one more example. Count the number of valence electrons in N2H2. So it's very similar to the last one, except we have 2 less hydrogens. So we have N equals 5 plus 5, which is 10 valence electrons. And then H equals 2, because 1 from each hydrogen. So 10 plus 2 equals 12 valence electrons. Now, once again, step 2, we can't put H in the middle because it only forms one bond. So we're going to put ends in the middle. So here come my ends. N, N. And then I have H's. We only have 2, so I'll give them 1 to each nitrogen. And then I'll connect. Oh, sorry, that's the next step. Oop, jumping ahead of myself here. Okay, put a covalent bond. Okay, we're going to do that and connect them together. So I'm just going to redraw H, N, N, H. And then add electrons to satisfy the octet. H only has 2, so H is good. We're going to count the number of electrons drawn and subtract again. So we had 12 to start, and I drew 2, 4, 6. Did I count this right? 10. Yep, I did. Okay, so I drew 6. So I'm going to count the zip. Okay, so 12 total minus 6 electrons drawn equals 6 electrons left. That means that's what I get to draw. Okay, only is 6 electrons, no more, no less. And we draw all of them. We use them all up. Okay, so down here, I'm going to draw I'm going to draw H, N, N, H. Okay, and now I'm going to put on 6. So I'm going to do 2, 4, 6. When we get to the next step to check to make sure, when we check that they all have an octet, okay, and ends, this one does on the right, 2, let me go highlight here. Thank you. 2, 4, 6, 8. So this nitrogen is good, but this nitrogen only has 2, 4, 6. It doesn't have an octet. So what are we going to do? Well, I didn't type this out in the step, so I will after we draw it. Okay, so I'm going to draw what happens because the nitrogen on the left doesn't have an octet. So what can happen is this pair of electrons, the lone pair, it feels sorry for the nitrogen. It can share them in the bond equally. So what happens is I draw another line and I don't draw the dots underneath that nitrogen above. And now let's check to see if they each have 8 and then how many electrons we drew. 2, 4, this nitrogen on the right has 2, 4, 6, 8 because these are a nonpolar covalent bond. Those electrons are shared equally. The one on the right, 2, 4, 6, 8, they are all good. Now let's count the total. 2, 4, 6, 8, 10, 12. I drew 12 electrons, which matches what we totaled in step 1. So this is called, let me type it in and type in what we did. Okay, so this is called a double bond. So a double bond has 4 electrons. Why 4? Because each line represents 2 electrons. So now I'm going to tell you something to add to your notes so that about when to use double bonds. So if you run out of electrons when trying to satisfy the octet of the central atoms, create we'll call them multiple bonds because sometimes you could even have a triple bond. Okay, so here we're going to say double bond in our case. You're going to create a double bond in which the electrons in the bond, I don't know why that's spacing like that, sorry, in the bond are shared equally. And that's the 4 electrons in the bond are shared equally for both atoms between both atoms. Thank you. Let me know if you have any questions.